So far, in simplifying radical expressions, we have assumed that all variables represent non-negative real numbers. What happens that's different when variables are allowed to represent negative real numbers? In order to see this, let's consider an example. Let's consider the simple example of 4th root x to the 4th. Now, in particular, let's see what happens when x is negative 2. Well then, negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2, which will be 4 times 4 is 16. But what's the 4th root of 16? The 4th root of 16 is positive 2. So at least when x is negative 2, the 4th root of x to the 4th is the absolute value of x. Will that happen for any negative number? Well, yeah. For any negative number, the 4th root of x to the 4th is going to be just the positive version of that number. What about positive numbers? Absolute value doesn't do anything to them. So yes, in general, if n is even, the nth root of x to the n is the absolute value of x, not just x. What about odd? Well, if I take an odd power of a negative number, I get a negative number back. That's no problem. So with an odd power, and then the same root, I do not need an absolute value. I only need to introduce this absolute value. Now there's a small simplification to this we can make, because frequently we're not just simplifying the 4th root of x to the 4th. What about the 4th root of x to the 8th? Right. In general, right, 8 is 4 times 2. So when we were not thinking about signs, we would say it's x squared. But do we need an absolute value here? Well, again, let's look at what happens to negative 2. Negative 2 to the 8th power is 256. And the 4th root of 256 is positive 4. On the other hand, negative 2 to the 2nd power, that's positive 4. Oh, so here we don't need the absolute value. Why not? If k is an even number, the absolute value of x raised to the kth power is just the same as x raised to the kth power. Right? Because if we take an even power of a negative number, we still get a positive number. How do we simplify the nth root of x to not just the n, but to the k times n? Well, if n is odd, then there's no complication. The nth root of x to the k times n is just x to the k. In this case, it would be wrong to include an absolute value, because if k is also an odd number, then if x is negative, this whole thing will be negative. If n is even and k is odd, the nth root of x to the k times n is the absolute value of x to the kth power. In this case, we must include the absolute value. It would be wrong to leave it out. If n and k are both even, the absolute value doesn't matter, since the kth power will always be positive regardless. So the absolute value really is there, but it's not doing anything, so we don't have to write it. Alright, so I'm going to give you just a little bit of practice on these. I'm going to have you try 3 examples, decide which situation each one is. Simplify each of these radicals. Pause the video and try this now. So 9 is 3 times 3. So the cube root of x to the 9th, that's just x to the 3rd. Since the 3rd root is an odd root, I don't need an absolute value. And in fact, it would be wrong to have one. Now here I'm taking the fourth root. The fourth root is an even root, so I will need an absolute value. 20 is 4 times 5, so I'll have absolute value x to the 5th. Now in this case, I have to leave the absolute value since this is an odd power, so it makes a difference. What about in this case? Even root, so I need an absolute value. 6 times 2 is 12. So this is going to be absolute value of x squared. Oh, but the absolute value of x squared is the same as just x squared, since either way this is always positive. So in this case, the absolute value is there, but I don't need to write it.